Hey, good morning, good afternoon, good evening, depending on where you are. I hope everyone's having a great day. Thank you for joining us for today's Penguin Solutions webinar on 5 key design considerations for AI and HPC infrastructures at scale. My name is Mark Siemens. I'm part of our Penguin Solutions team. And if you're not familiar with Penguin Solutions, just a quick word, we're a partner and a technology provider who are 100% focused on the design, the build, the deployment, and the management of AI and high performance computing infrastructures at scale. We've been focused on this for over 2 decades. And what we're going to share with you today, hopefully, will be some valuable information specific to the area of this new era of AI training infrastructures. So your time is valuable. So let's go ahead and dive into the content. What we're going to cover today is just a little bit of background on AI infrastructure, kind of the purpose of the infrastructure, where we focus, and give you a quick example of how it all fits together. We'll touch on some of the deployment challenges that you're going to face. It gives context, I think, for as we talk about the design considerations. It allows us to focus on, what are the challenges we're making sure that we address, and then we'll get into some of these key design considerations, and we'll have a little bit of time at the end for Q&A. So let's go ahead and jump in. So when we think about AI infrastructure, what we're really thinking about is an enterprise platform designed to support these advanced AI training workloads with optimal performance and stability. And the key here is at scale. And you'll hear this a little bit as we get into the details about how when you start to scale these environments, it introduces some unique challenges that we need to face. The picture on the right isn't a stock photo. It's actually, and we'll refer back to it a little bit later. It's actually a picture of an actual large-scale AI training cluster, and in fact, it's just a small sliver of the cluster that we put together. But we'll use it kind of as an example, refer back to as we go through the overall presentation of the material. But if we look on the left, what we think about when we're delivering these AI training infrastructures with our customers is two things. One is, what are the workloads they're looking to execute? And that's kind of the top half of the equation. We're thinking about what are you looking to run on this infrastructure. And then where Penguin Solutions focuses, and what we'll talk about today in more detail, is the actual design and construction of this infrastructure, kind of starting at the bare metal hardware, moving our way to the network, through to the software, and then to the ongoing system management. Now, as we think about these systems, one of the things to keep in mind is that you've really got two major phases you're going to be dealing with as you go through building and deploying this infrastructure. The first one is getting to production, and ideally doing that on time and on budget. And then getting to that magical day, your first day of pure production, and then following that, getting to a long, hopefully, era of very smooth operations where your organization is going to reap the benefits of AI. But if we click one level down, you can see that as we think about getting to production, there are steps we go through and phases we go through: a design phase, a build, a deployment phase. And then as we get to production, we've got additional phases. One, the overall management of the system, and then some other things that happen over time. System expansion, which is going to be almost inevitable as you look to increase the scope of what you're doing with this infrastructure. And then the ongoing evolution of how the system runs. So what we're going to touch on today specifically are design considerations, but we're going to do it in the context of thinking about the whole problem that we're trying to solve. So if you think about challenges, kind of challenges exist at each one of these phases, and this is just experiential for us at Penguin Solutions, and really it's having hit these challenges in the past and then developing predictable and repeatable solutions. It's some of what we're really trying to share with you today, and as part of this ongoing series of webinars that we'll deliver. It's about sharing this knowledge and sharing our experience so that we all get better at this together. But as we think about the design, the challenges really come from the fact that so much of this is new for many of the people who are going to do this work. It's new networks, it's new processors, it's new software, it's new runbooks and execution challenges that come up that are just different from the way enterprise IT has worked historically. And in some cases, those differences in terms of processors networks create gaps in people's understanding and just in your experience. There's nothing wrong with it. It's just that if you haven't done it before, it's going to be new and there are new challenges to address. So as we look at the infrastructure, one of the things with these infrastructure components is that you've got two dimensions you're going to be working with as we look to maximize the value from AI infrastructure. The first dimension is what percentage of the nodes that we've deployed for training do we actually have up and in operation for production workloads? The other dimension is as a percentage of the total throughput the system can deliver, what percentage are we actually getting in terms of the efficiency, the network processing, and the throughput? And it's these two dimensions that combine to give us a sense of the total throughput we get from our environment and the total value. So for example, if we had 100% of the nodes working and the environment was working at 100% efficiency, we'd be getting optimum value from the investment we had made in AI infrastructure. But similarly, if we got to a state because of failed nodes, maybe lack of parts to repair those nodes or delays in getting those parts to where we have only some fraction, maybe 70% of our nodes in production, and only 70% of effective throughput from the environment we're running in, we find ourselves where we're getting what? 70% of throughput. That's not actually correct because these two factors are multiplicative and they rely on each other. So if we had the situation shown on the screen here, what you'd find is that you were getting 70% of 70%, meaning 49% of the total throughput of what you had paid for. So you'd be getting less than half of the value of the infrastructure you had deployed because of operational issues that you might be facing. And the rest of that value was sort of sleeping away from you. And it's really these design challenges and design decisions that we make which help us squeeze that full value out of the environment. So let's take a look. First thing we're going to talk about is the fact that in these environments, power dictates everything. And if you haven't hit this yet, it's going to be something you're going to become increasingly aware of as you work in this new era of AI infrastructure. If we think about enterprise racks traditionally in a data center, those racks might consume 8.6 to 10 kilowatts of power per rack that we were running for things like Exchange Server or databases. As we entered the era, even a generation ago, of these AI processors, what we saw was that powering a rack, even if it just had two of these AI nodes in it, consumed 13 kilowatts, or maybe a little bit more than that, of power to power that rack. More recently now, as we've moved with the later generations of some of the NVIDIA technology to the H100 processors, you take that same rack with two nodes per rack, and now it requires 22 kilowatts of power to power the rack. And if you want to put more dense environments in place, maybe putting 4 nodes per rack, you're up at 44 kilowatts, which is, again, tremendous amount of power. You can see where this direction is going. And for those of us who recently watched some of the GTC announcements from NVIDIA, exciting information and kind of an exciting future coming down the pipe, one of the things we saw was a new era of B100 technology and a new rack design. But if you look at the power required for that, it's over 120 kilowatts for that rack of incredibly powerful compute. So, what we're thinking about is as you design, you need to be thinking about the power characteristics of your data center, which is then going to drive cooling requirements and actually the physical layout of how your systems are going to go in. Because, if you could do 4 nodes per rack for a 32 node system, which is kind of referred to as a pod, you could do a design that looked like this, right? Kind of compact. 10 racks would get you from the compute portion of your infrastructure to delivery. But if you're going with a lower power environment within your data center, that same number of nodes, right, split to 2 nodes per rack, would require a significantly more amount of floor space and a different cooling profile. So you got to be thinking as we begin, what's the environment that I'm working in and how do I lay out these systems? And if you think about all these lines that say blank and blanking panels, if you thought, well, who would deploy that? with 2 nodes per rack, it's actually quite common, again, dictated by power. If we go back to that picture I showed earlier in the original slide, and if we could find a way to walk around the corner and look down one of these aisles of compute, here's what you'd see. Rows and rows of these racks. But if you look, and I'll zoom in on one of the racks on the left, there you go, 2 nodes per rack, really dictated by, again, the power requirements of the data center. And that data center space, as we build systems out, you can see even for a small system, takes us from 25 racks being required, if you can get 2 nodes per rack, down to 17 racks required. And so as you scale these items and these solutions up to much larger AI footprints, we're going to be talking about a whole different look and feel to what you'd be putting in place, both from a physical layout and from a cooling perspective. So kind of consideration number one to think about is start your design in the data center. And if you come to Penguin to discuss any work on a solution like this, that's probably one of the first questions that we'd be talking about is what's your data center look like? And let's start designing with that in mind. So next, let's talk about running. You see the picture on the right here, and what's sort of running got to do with these AI infrastructures. And I'll relate this back, but the reality is the network is the platform in these environments. And the reason I picked the picture on the right, and if you're in all interested in running, and I'm a big fan of running, the running on the right that you see the picture of isn't track and field, it's what's called cross-country running. And the thing that's unique about cross-country running is winning in cross-country isn't about having the fastest runner. It's about having a whole team of runners who can all run quickly, because in cross-country, it's really the ability to get your entire team across the finish line that dictates your ability to win a race. And that's the same as workloads executing within these AI training environments. Everything executes at the speed of the slowest connection, the slowest node, and the slowest link, because these training systems run in this continuous loop of executing compute and then resynchronizing and communicating and sharing information between all of the nodes. So if one node is working slowly, or if that communication is slow, the entire operation is slowed down. So a single slow connection can slow the whole thing down. And in many cases, a significant portion of the wall clock time when you're doing this training is spent on this communication activity. So your ability to make speed ups occur in the network can really pay huge dividends. One of the things I saw recently that was interesting was an entry, a blog entry that was published by Meta, as they just recently, and this was just a couple of months ago, went through the process of finalizing the deployment of a very large training cluster. And some of the information they shared about these large scale deployments was the fact that when they initially deployed it, even though they did it with good practice and following the rules, the initial performance they saw within the network environment as they deployed it was as low as only 10% of the total target performance. Now, they didn't see this when they deployed small clusters. Small clusters, they could get working well relatively rapidly, but as your clusters get larger, the network criticality and the requirement to do this very precise tuning, testing, and optimization of the network became critical. Now, of course, you see in the diagram on the right, through tuning, through the adaptation of the configuration, they absolutely got the network performance all the way back up to that 90%. But the reality is, when I showed you earlier that 70% number we looked at, it's not difficult at all in these environments to be operating at a suboptimal rate. And it's really through experience that you're able to get that top performance out of your environment. So as you go through your design, and this is just a picture I pulled from one of our solutions architects on our team that kind of shows the interconnected nature of these clusters, you start to see why that statement of the network is the environment becomes so true. So kind of consideration number two is focus, focus, focus on the networks, and the reason I put the parentheses with the S in there is because you're almost undoubtedly going to be dealing with an environment where you've got management networks, where you have what are called front end networks connecting to your storage for traditional system access. And then you're going to have back end high performance networks that are connecting all of those AI GPUs that are running. So it's the combination of all this that all has to be running at peak performance. So it's a huge area of focus as you go through the initial design and deployment of your system. So what if it's not running well? Well, it's easy to see that your system's not running as fast as it should be, but sometimes it's incredibly challenging to figure out why. There's a lot of moving parts to this. Every system, every node has 8 GPUs in most cases, and it's got 10 or more network interface cards, which means 10 network interface cards, 10 transceivers if you're using optical connected networking, 10 copper or optical cables that start to connect these things together. And when you start to add network fabric infrastructure, memory, CPUs, firmware elements, and the connections to this very high performance storage that's required, it's a lot of pieces. In the picture that I showed you of that large cluster earlier, there were over 40,000 network connections that it took to get that system completely connected and operating. And really, when you talk about the failure of any one of those, impacting the performance, this ability to track down the root cause of issues is something really from the very beginning you have to be thinking about. How am I going to do that effectively so that I can get that system up to full performance? So a couple of things I'll touch on. Number one is you should really be designing up front this process, methodical process that you're going to be able to use to be able to validate the performance of the system, and then to track down on a methodical way down to the component level what must be the root cause, right? And so should be relying on automation. You see on the right, I again stole from our team a little bit, but this is some examples just of a large set of run books that we have around automated workflows and triage processes that we run. And one of the other things I'll share with you is some really interesting technology that's come out of the deployment of these large systems. And it's some patent pending technology that our Penguin teams developed, which uses what's called accumulator technology to very rapidly do the isolation within a large system environment in a non-obtrusive way, to be able to run a scan, do paired comparison testing, and to be able to rapidly isolate, hey, the source of the problem is this node. And then once we get to that node, we can drill in to find out what the source is. And so as you go through this process of deploying these systems, you need to have a plan for how you're going to isolate performance issues, and then ideally get access to some advanced technology that'll help you get there. So consideration number 3 is plan to find the needle in the haystack. Moving forward, as you're going to get going, remember we talked about this process of design, build, deploy, and getting to day one production. What we really want to do as we're designing through to that is to be thinking about how are we going to avoid a false start. As I put in the slide here, nothing kills enthusiasm about the system more than either slow system performance or people seeing failed jobs occurring. And so this is all about you considering factors around stability, performance, throughput, and anticipating the impact of system outages. So, what can you be doing to get to production? And once you get there, to know that I'm stable and I'm ready to go, and I didn't pull the trigger too early to turn this system on for users. And to do that, one of the things we recommend is to really begin with the end in mind. And before you even get through the meat of the build process, to have established a set of criteria that says we'll know we're ready to go to production when the following criteria are met. When we've got more than X% of our nodes healthy, burned in, and showing great performance. When we're hitting greater than this percentage of network throughput, right? When we're able to run these sample workloads repeatably on an ongoing basis. So you establish the criteria, and then you start your march to validating that. And so a couple of the areas that we focus are on network readiness. And when we say, oh, is the network ready, I drilled down here into just a high level set of some of the different tests and checklists that we go through and that I'd recommend people think about as you go to do this. It starts literally with, are the NICs powering on, all the way through to, are we getting good physical links? Do we have high quality connections if you're using optical transceivers? And then you work your way up to actually doing networking and monitoring packet flow and packet loss. And then once you feel like I've got the network solid, you turn your attention to the nodes and thinking about your process for doing the node provisioning and the validation, and then qualifying nodes one at a time, and then starting to build up collections of nodes into larger and larger subsets of the cluster so that you're building up and validating as you go. And if you hit issues, you stop at that point and obviously remediate and then kind of continue your journey. But until you hit that target, right, that it's not go live time. So this is about starting with the end in mind, having your criteria, and then executing to those criteria sort of on a relentless basis. So define production ready at the start. And then our last topic to touch on is the fact that getting to production is really just the beginning, right? And that's a critical day. When you flip the switch, and you'll find when you take these systems to production, it's really difficult and it's really unsettling for an organization to have to take the entire system out of production following that, which is why you want to be so confident that day that you flip that switch on, because once it's on, it's on. But once it's on, you still need to deal with real life requirements shown here: firmware updates, OS updates, component failures, job execution issues from specific users or groups are all going to be things that you're dealing with. And so one of the things we recommend as we think about the infrastructure portion of this is to really focus on the management of that infrastructure, and kind of taking a holistic approach to the health monitoring, to the throughput monitoring, and also to the ability to roll out these ongoing updates, changes in a non-disruptive way. So one of the things, again, that we've developed that allows people to automate and streamline this process for administrators is a whole collection of software. This isn't the only thing that is out there to do this, but I do want to highlight this kind of purpose-built platform that Penguin has called Clusterware. That's kind of a one-stop shop for bare metal deployment, for ongoing health monitoring, for implementing system changes non-disruptively, and for providing that performance monitoring as well. And so it's kind of your control panel or your air traffic control for monitoring everything that goes on with the system. So again, whether it's this framework or something else that you choose to take on, as you begin the deployment and design of your system, be thinking about what are we going to do to ensure the level of uptime and throughput that our users deserve. So plan for production management and expansion. So as we get through that last recommendation, kind of we'll go back to summarize the fact that driving these great AI outcomes really begins with a great design and a great plan. Start in the data center, ensure access to great fabric expertise, because you're going to need it, and not just for deployment, but forever, because the health of these systems is all about the performance of the network. Define what it means to get to production and to be ready to pull the trigger to have your system fully go, and then flip the switch to on, and both enjoy the benefits of AI, but also provide the tools to be able to deliver that great ongoing user experience. So with that, I think what we're going to do is pivot over. We've got time for a couple of questions, and I see there were a couple of questions that came in while we were doing the session. So maybe we'll go ahead and pivot over and move to some Q&A. So the first question that's come in is, given the escalating power requirements for these AI systems, will enterprises likely be looking to deploy these dedicated systems into specialty data centers or colos? Yeah, that's a good question. And the answer is almost undoubtedly, in many cases, going to be yes, for the reasons that I mentioned earlier, in that if you look at the differences in power and cooling requirements, including the more frequent use of things like direct to chip liquid cooling, and even as we look forward, immersion cooling, where the nodes themselves are immersed in tanks of non-conductive fluid to cool these systems, it increasingly becomes something which the standard enterprise data center wasn't designed to take on, and therefore perhaps a colo environment that's been purpose built for this AI style infrastructure could be a good fit. So yeah, as we work with clients, we are increasingly having that conversation where the customer is saying, you know what, I think the fit for this may be better into a specialty data center. Can you work with me to help identify that and think about how we can deploy and manage systems in that environment? So great question. And by the way, before we get to the next question, I want to highlight just a couple of things on the screen here. First and foremost, this video that we're doing today is part of an ongoing series. And so we're going to be doing a follow-on video on June 6th around that topic of production readiness that I talked about earlier. We'll kind of dive into that topic and think about what are the steps, what types of network validation and system validation should you be thinking about as you look to bring your infrastructure to production. So if that would be interesting for you, join us on Thursday, June 6th. As well, we're only going to get to one more question probably here. And so if you have a question you'd like to ask, or maybe something you'd rather handle offline with someone on our team, you can click the QR code labeled Connect, and you'll fill out a short contact form, and we'll reach out and we can do a short call to talk about your specific question and your specific area of need. And likewise, if you're interested in a little bit more in-depth coverage about the structure and deployment of these environments, scan the ebook QR code on the right. And again, you'll go to a download link where you can obtain a digital copy of an ebook we've provided on AI factory infrastructure. So let's take one more question. It says, can you give an example of a system managed process that your team focuses on in order to drive higher levels of system utilization? Yeah, that's a good question. You know, one maybe non-obvious thing I'll touch on is the work that we put into and the value that we see from doing upfront work planning for the on-site spares depot and spares inventory management for the systems that we're putting in place. You know, our team spends time, and we've actually got a pretty large basis of historical track record of failure rates for different components, which then drives us to stock ahead of time a whole collection of spares, spare GPUs, you know, spare network interface cards, cables, transceivers, SSDs, NVMe drives, because again, this whole thing is about keeping as much of that infrastructure up as you can at any given time. And our ability to get systems rapidly back into production, in many cases, is just as fast as getting that part that we need, replacing a failed component, re-provisioning and reintroducing a node back into the cluster. So, you know, we sweat the details, and we do spend time looking at that inventory and on-site management to be able to, again, provide that highest level of uptime. So with that much said, I think we're at time. And again, there are a couple of other questions which we'll follow up with people on individually. If you have a specific question, again, you'd like to ask us, click on that or scan the QR code for Connect. And we look forward to seeing you and hopefully having you attend one of our future webinars, including the upcoming one on Thursday, June 6th on AI infrastructure and production readiness. Thanks for your time today. Hopefully this was valuable. We'll look forward to seeing you in the future.